Okay, previously we did the tree height study that let's reveal that our scenario was the land managers learn a great deal about the history of the forested site based on the amount, distribution, and height of the vegetation cover, and the impact of wildfire and disease, the growth of the young trees, and the presence of habitat features favored by certain wildlife species are all important types of information that can be derived from LiDAR. So we have the LiDAR data, and most of this information is currently collected through time-intensive ground surveys and often in remote locations. Increased efficiencies in data collection will be welcomed by land management agencies and organizations, and the Nature Conservancy Virginia chapters want to use LiDAR to estimate the extent of various successional stages using vegetation height as a surrogate for age. And this knowledge will allow the land managers to better understand what restoration and management techniques may be necessary to maintain a diversity of forest communities and species. So the LiDAR provides the opportunity to characterize different strata in ways previously not possible from satellite imagery. The canopy height can be determined by subtracting the bare Earth surface DEM from the first return surface DSM. And now we do not have to. We have the data and we performed. We look at the first one we did was set the environments. Once we set the environments, we did a base map showing the location of the LAS dataset. We had the base map. The base map we created, we used the tool create LAS dataset, and we put the parameters there. And what the data we got was each point. And we use a Python code to look at the point spacing. And the second step we did was the DEM, which is right here, DEM, and then we have SDM. Going to open SDM. This is DEM, and we have a SDM. Okay, DEM. Let's see, DEM, SDM. So DEM and SDM. Okay, we created DEM and we created SDM. So let's review DEM. So the DEM is a bare earth model. DEM is a bare earth model with a ground classification that shows points that are classified as ground compared to a DSM that shows first return data from all classification codes. And we can access this data on the appearance tab. So appearance tab, once we click this, and we have a appearance tab, and this is max. So then we will have a GWNF, which is the George Washington National Forest. Okay, so that's the first step. We have excuse me, we have those dots. And we have a DEM, we have SDM. DEM that we used the for SDM. Back up a little bit. So the George W. National Forest, this LAST data that we created using the create LAS dataset. The LAS dataset, that we created using the tool create LAS dataset, and then we used based on this, and we created the DEM. I just introduced what is DEM again, and using this tool that we go into DEM, which is Alpha raster DEM is dataset to raster, that we use the field is ground point. And once we created SDM, we use the elevation. Okay, elevation that the same, we based on this and create an SDM. So once we have an SDM, now I'm going to continue, which is the new part in this video, the calculating vegetation height. We're going to determine the vegetation height using the bare surface DEM is subtract from the digital surface model. So DEM will minus DSM. In the catalog pane, we will copy and paste DEM and DSM, right click on it and go to copy and maps and paste. Okay, DSM1, I'm going to change the name to height. Okay, once we have height, that what we will do is use the tool analysis and go to tools. So once we have the tool, we will search the tool called minus spatial analysis. Okay. Analyst. Hope it's not a script tool. Minus spatial analyst. I think I just minus, okay. Spatial analyst tool. Input raster, this first one will be DSM and minus the DMX. Okay, then I will just say minus, click run. And a raster dataset that has a floating point or decimal value does not have an attribute table. We can just change a floating point data type to an integer, and which we will provide the raster file with an attribute table. The integer tool and will convert each cell value of a raster to an integer using truncation. That it will delete all those floating numbers, and we will have all. I will open the attribute table so you will see before and after running the tool. Okay, we just wait a little bit, and I'm going to bring some documents up. Okay, it takes some time. Hopefully the computer is not too slow, okay. For some reason, okay. Still running. For the DEM and DSM, I need to see what's going on there. And when I'm done, I'm going to design the final map, okay? The final map, it's kind of interesting. We will put things together and make a map. Still running. Right now it's 80%, so we'll have to give a little patience. Okay, it's almost done. It's still rendering, I know. It is still rendering. Okay, that's... What happened to my solar panel? Alright, well, while this is running, I'm going to change my solar panel and see what's going on. Okay, so that's this one, okay. I'm gonna go to symbology. Low to height. Oh my god, unique value am I gonna render all the way. Something wrong with this map. The data. The calculation didn't match. Just wait it. Okay. I'm sorry I got distracted. I gonna track this real quick. Let it load. And I'm going to go back here. Okay, so that's our height. Once we have a height, I'm going to right click on it and let's look at the attribute table. And we will see some floating and we will use the tool to calculate. Okay, for some reason computer is slow now. Open attribute table. See, we have the floating point here. Cannot open attribute table. And then I'm going to integer, go to tools, integer and spatial analyst. And input, it will be minus. And the output, it will be integer height. I'll just type integer height. Click run. Alright. So I'm gonna go back to the previous one. Let's change the color scheme. Okay. It's loading. While it's loading, let me go back here. This one is running. It's gonna take a while. We will look at some of the questions here. The first one, let's see the projected question 3. Let's back up to the question 3. We can look at question 3. Let's see, where's question 3? Question 3. What is the town's location relative to the GN? Okay, town of Harrisburg is to the east, and Staturn is to the south. Okay, let's look. Can I go back here? Yeah. I have the world imagery. Harrisburg. I'm going to uncheck this. Not familiar. Oh, right here. Harrisburg. Okay, Harrisburg and this one. Okay, right here. So south is here, east is Harrisburg. Our little pot is right here. So that's here. Okay. You can draw a map showing the question 3 is where is the town? What is the town's location relative to the national George Washington National Forest? This right here. To the east is Harrisburg, and to the south is Staturn. And you have to zoom out, and that's how you find it. And number 4. Question number 4, what is the range mountains this located? What is in range? The mountain. LASD. So our LASD is 1569.55 to 322692. So let's look at the units. Go to property and we have elevation. Elevation source. Let's look at source. US foot. Yep. It will be foot, okay? Alright, foot. Alright, and then question number 5. What is the unit? Question number 5. Okay, what is the unit for elevation? And what are the lowest and highest elevation represented in the DEM? Now the highest of the highest elevation of the DEM is 3 226.92 feet. And the lowest elevation is 1569.55 feet. Okay, yep, 1569.55 and 326.92 feet. And question 6 is write a brief spatial description of the LIS data frame. Okay, then we will move to question 7. What is the unit for elevation and what are the lowest and highest elevation represented in the DSM? So now we're going to go to DSM. For the DSM, I think something wrong is here. That I got integer. Let's see the integer tool. It is still running, so let's just wait for it. Okay. DEM. Okay. We are on this layer. Yeah, it is still running. But if get rid of the integer, I have a 517, which is close to 1622, and the other is 3226, and I lost 1,000. For the height, I think maybe I did wrong. I might have to redo it. Okay. Once this is done, I'm gonna redo it because input raster, the first one, it should be DSM and DEM. I cannot remember. I know I recorded it, but okay. And then we have a question number 8. What are the lowest highest value in high raster? And then we have how many cells have a value over 190, and how many cells that we have value less than 0. And after that, we look at the data and then we will produce the map integer height. We should have integer height and the count. And we have to describe, 11 is describe the distribution of the cells that are less than 0. And what does imagery in the problem areas show? We have to look. And once we finish that, we will reclassify and symbolize the vegetation height. That's what we have to do. Once we have the vegetation height, we reclassify and we will relabel it, and we should have everything. Okay, now we get everything perfect. Okay. Okay, my bad. So calculating, I should be in height. I didn't open height. Okay, this should be height. I didn't open it. That's why I say I'm gonna redo it. Okay. Let's go back to DSM. I'm gonna remove these and remove these. Okay, that's our DSM height is here, so I'm gonna close it out. Because it's which tab you are working on, it's very easy to make a mistake. That's what I did. I made a mistake that I didn't work on height map. So, okay, height is right here. Let me fix this real quick. This one doesn't sound right. Let me go back to no, not discrete. Oh shoot. Okay, I'll just let you render it. Okay. Oh, that's still fast. Okay. I have a lot of color, you know. Let me see what's going on here. It doesn't match the map there, so. I might have to redo this solo. Symbology. There. This is the correct one, okay? That we see this is the place you should put the sun panel. Okay. Which one is the one before I cut? I don't need this. Let's see. Okay. Isn't it this one? I guess, yeah. Let's try it then. Symbology. Okay. I guess these are the same. Remove area solo. Okay, I guess this is the one. Let's see. Not this one. This one is correct. This one obviously not. Let me change a color scheme first. It should be more yellowish. Show all. Yellow-ish. Doesn't match that. The color scheme doesn't match. Even this doesn't match. This is the scheme, but let me save it. I still have to find my layer. This is global solar map. Let's see. This is the same. Did I have to calculate building raster? Zoom to layer. Oh, this one is not here. Remove. Alright. I will come back here. Okay. So let's finish this first, okay? I'm sorry I got distracted. I just like to work on it and fix the thing. It took us a long time. Okay, now we have the minus tool, and for the minus tool, we will recalculate it. Minus tool. Okay, the first one is DSM. Height. This one, I don't have DSM here. I'm going to add DSM. Okay, now I have a DSM here. I'm going to do symbology. Do the elevation one. Okay. And then for tools, minus the first one, DSM, minus the DM. Now this time I will change it into height. Click run. Okay, while it's running, I'm gonna come back and look what's going on our solo map. Okay, the solo map. Building raster, I'm gonna remove. Aerosol extract. Let's go back a little bit. It's in San Francisco. Once I extract, what do I do? Let's see. Analyst, we do aerosol radiation tool. Oh. It doesn't matter the issue. The issue was zoom to layer. The issue was extract by masks. Okay, I did that. I think I could just redo it real quick. The first one, I will do create LAS dataset analysis. Let's look at the tool again. Create LAS dataset, and I'm gonna put input file. That's this one. Okay. Click open, and that's fine. And input, that's fine. Lambert. Conformal. Curve map. Nope. Okay. UTM, yep. And then nope and nope. Okay, click run. Okay, so now I have this data set. and I don't have to do anything. I will convert this tools that I will LAS dataset to raster. Okay, input and output raster, that's fine. Okay, output raster and value elevation, binning, and this one we will change it into maximum. Linear, floating point, cell size, and 10 and 1. Okay, and then run. Okay, I do not have to extract by masks. Okay. I don't have to extract by masks. Let's see. Let me uncheck. I'm gonna remove this one. Okay, so zoom to layer. Does it take time to render it? And then we have to area solar energy. I think something wrong with this layer. I'm gonna delete it. OSD. Select these and appearance. All points, yes. Find 1, 2, 3, 4, 5. Zoom to layer. Oh no. Not this data set. I'm gonna remove it. Create LAS data set. Okay. Where is my data? Not Virginia, that's why. San Francisco solar data. Okay, go back. Okay. There. Let's go to appearance. Okay, 25. 1, 2, 3, 4, 5. I think something wrong with those points. Okay, once I have this, I will convert. Okay. LS data to raster. The first one is this, okay, and I will have a maximum elevation. Okay, 10, 1, maximum, binning linear, okay. Click run. Then I should have a raster. Oh, Remember, I have to cut buildings. Folders. Okay. Let's cut the buildings. San Francisco solid data. P3. Okay, layers. Buildings. And then I will do extract by masks. Tools, extract by masks. Okay. That I will have gold, and this will be our building. Okay, click run. Okay. Remove. There. Remove. Okay. Now I'm going to calculate the solar. Calculate the solar. It will be area solar radiation. And input, it will be extract area. Okay, outside. Multiple days. No, I just do within a day. Not July. Cannot go back. I was June 21st. Click OK. Alright. So 0, 24.5. And I can just do 183. No, I already did that. Okay. That's it. I'm gonna run. There. Uncheck these. Uncheck these. The same value. Something wrong here. Okay, the same value. Okay, let me calculate again. Tools and area solar radiation, and the same. Okay. This time I'm just do within a day. 200. Latitude, select. Latitude is a little weird off. Okay. And pick a date. I'm gonna do 183. Click run. It shouldn't have a huge change. So there, it's a little change. Let's do January 1st. Okay, click run. Nope, not a huge change. And you can see this is low. And what did I do for this one? No, this one. Something must be wrong here, and I need to figure it out. Maximum. Yeah, the cell size is maximum. Oh. something wrong with this layer. There. So it's wrong. I know. It didn't using. Let me calculate it using this one. Within a day, run again. See? Something is wrong here. Dormitory data, create, extract. Okay, I have to extract LAS. Okay, I think not environment, tools, extract by masks, extract LAS. Yeah, that's for the 3D. Let me see, extract these target folder. That's for the 3D. That is for the 3D if I extract it. Output folder. I'm gonna put it in my folder. Go to, no. Desktop, I'm going to put into my folder. Click OK. Okay. M2. Click run again. So while we are extracting, let's check here. Okay, the minus is already here, and height. Okay. Now we have height. Once we have height, I will do integer. So let me right click on it. No, open attribute table, integer tool, height, integer height. Then I should have. Then I have a 0 for the height. -6 feet. And it's similar to 274. That's what I got. Wait, this is running. Let me look here real quick. Oh, this is still processing. Alright, this is a little crazy right now. Because I found there was a problem, and I might have to redo it and fix it. But I do feel this is very interesting. You can put all the buildings and manage those buildings and calculate those. Okay, click run again. This is not running. This one is running right now. Okay, the question number A. Alright, question number A. Question 7, what is the unit? What is the unit? Okay. Question 7, the highest. The highest elevation of the DSM is 3226 feet, and the lowest elevation is 1,622 feet. Okay, and what are the lowest and highest value in the height raster? Okay, the lowest elevation in the height raster is -6 feet, and the highest is 1,270 feet. And how many cell values over 160? It will be there are six cells with a value of over 196 feet. So let's see. And question 10, how many cells have the value less than 10? Okay, there are 836 cells with a value of less than 0. Okay, waiting this to run. This is 80%. Let's just wait for it. So question 9, let's say again, how many cells have a value of over 196 feet? There are 6 cells with a value of over 196 feet. And how many cells have a value of less than 0? There are 836 cells with a value of less than 0. The 11 cells with a value of over 196 feet are insignificant. However, we should investigate the cells with a negative values and search for possible reasons. And we will open the attribute table and highlight each row with a value less than 0. I think something wrong with this because I cannot open the attribute table. I just have to see. It's a raster data. Technically, we should have the cell table. Okay, now it's done. Gonna close it out. Height. Yeah, that's how it look like. Now we have the attribute table. Something is wrong. DEMandDSM. DSM. DSM. DSM minus DEM. I could have these. So I don't get -6. I'm gonna rank it. Value of 916. I don't have that. Value. I have a 0. I shouldn't. Something wrong is here. The data, I don't get it exactly. Maybe the method they changes or the algorithm in the system. I have to rerun it. I don't get 196. I got 0. am less than 0, I have a 0. And if you say how many cells that I have for 0 value, I have a 140, 140. Okay. I do have a table here. And now I'm going to do my map. We are ready to export it. We already done all the analysis. So here that we open the attribute table, we can observe it. Oh, we have to do reclassification so I can see a lot better. Since the cells is a lot different. Oh, I still can reclassify it. Okay. It shouldn't have a huge change. This is the height, tree height. Okay. Let's see. Okay, the reason why it wasn't successfully extracted, the reason was because, you know what I did? Because I have a thing there. I think something wrong with the data. Anyway, I'm going to go back to this one. That I will export it. Oh, I'm not gonna go back here. The building value, okay. There is something wrong. It's like right now I'm arbitrary ungroup it. I'm arbitrary like editing the legend, which is wrong, you know. Okay. Delete. No. Line up. Move up a little bit. Oh, no. up a little bit. Up. Up. Can you move up a little bit? There. There. So when I'm zooming, this match this, okay? This match this, okay? I could just highlight this. Let me see the neat line. Property. Page setup. Not this one, okay. Frame, okay. Frame, I'm gonna do... Okay, I'm going to do 2, 3. Okay, that I will highlight this. Insert a rectangle, which is right here. Okay. Double check. Symbol. Symbol. Gallery. Property. This color. 1, 2, 3. Click apply. There. So I highlight here, and then this is here. See? And now here it's a lot better. Let's see if I can activate this map. Let's do 22. Okay, and then let's do 20. I'm gonna do 18. $1,800. 1, 2, 3. 18. Pen. Okay, I'm gonna activate. Okay, 18. Yes, replace it. And this one is this, okay? So, this is in 3D, this is in 2D. And then you put some of the solar panel here. There, okay. Back on our tree. This is wrong. I think the data could be wrong. You have to do multiple and double check. all the year round, and you have to give us statistics and that you receive the best solar panel, the best results. Okay. Okay, back on out here. Now we're going to do reclassification. When we do reclassification, we have to do reclassifying and symbolizing the vegetation height. We must classify and symbolize the height raster, and we're leaving out the negative cells and the cells more than 196 feet high according to the following table. And the height and the type of vegetation and symbol reclassify value, we will do 0 and below. Type of vegetation could be arrows and no color arrows. And then, let's see, I only have a 1. Select 0 and zoom to layer. See? Oh my god. I have all these. Count, I have a 600. I have a 600 with something as a 0. Okay. 0 to, I have a 0 to 127. The 0, I have 600. 624 are 0. That's fine. And in this case, I will give up. I will say no arrows, and then it's this part could be arrow. Wow, that's interesting to know. And 1 to 5, it will be bush, not many. 1 to 5, okay. These, but here, let's see the bush, okay. So these area are bushes, according to our data. Bush, okay. And from 6 to 15, so 6, okay, to 15, these are shrub, no, previously shrub. This is a small rangan, light green, regenerative growth, and 16 to 25. 16 to 25, this area, wow, a lot of trees are growing, which is really nice. And from 25 above to the end, okay, this area, oh my god, those are trees already grow up. So now we know it's very useful using LiDAR data to manage those trees. Okay, if I'm zooming, and you can see those are very nice. Okay, the trees are all here in just one spot, and we use the LiDAR. We fly the airplane back and forth. So you go this way, back and forth, and we're collecting the height data. Okay, now reclassification tool. I will have to go back to map, clear selection. Once I have a clear selection, once I have a clear selection, that I will do is go to save first. Go to analysis and go to, no, I'll need tools. For tools that we will have is, we will do reclassification. Actually, I could just do symbology for classification. I still have to do reclassify. Integer height, value, output raster. Okay. Unique value. Wow, that will be crazy. I'm not gonna do that. Oh, actually I could. It just takes some time. Let me. Trees. Oh, hello. There. So basically it will be like this. Different height, but we will have a less classification, okay? Gonna collapse this. That will be crazy, okay? Go to tools and reclassify. Reclassify, spatial analysis. Okay, once I have a spatial analysis, that I will do is integer height and reclassify, yes, values. And I know there was a lot to reclassify. One, two, three, four, five. I will do one. Okay. One. One. Okay. And then for 2, from 6 to 15, 6 to 15, 2, 2, 2, 2, 2 until 15. These are tedious. Oh my god. 2, 2. Okay. And then 16 to 25. 16 to 25 will be 3. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Okay. And 4 is 25 above. Okay. Okay. 4. And then now it's easy. 4. And then 4. And then 4. Where is my 0? Okay. 0 is errors. Okay. 0 errors. Oh, 0 still 0. Okay. 0 still 0. I have 5 classifications. I have to finish these. Okay. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. Okay. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. Oh my god, that's a lot. I'm gonna cry. Okay, if you are watching this video, I'm not gonna stop. You could just skip it, okay? Or I could tell you a story. Let's just get through with this. You just have no choice. Sometimes you do GIS. Unless we could write Python. Oh, actually, I could do that. I could write a Python code and I just run the classification tool. Yeah, why not I do that? And then I don't have to change all those values. Okay, I can just assign values, write a code, that I can do that. Needs Python. Okay, I will explore. Okay, need Python. Okay, to do reclassification. Reclassify. Okay, I will put a note here, and next time I will come back, I will run this tool again. Reclassification, that's a good tool. I think I know how to do it in Python. How to do reclassification in Python. Let's just do it. Oh my god, I'm already cry. ArcGIS Python classification reclassify. Alright, let's do it now. Okay, reclassify for raster usage. Class field ramp, okay. Ramp table. Okay. There. So I'm gonna do it. Okay. I will use this tool. Oh my god. If not, I'm gonna cry here. Oh, I almost finished. So let's try it and see the same results. Okay. Okay. Using Python. That will save a lot of work. That I don't have to put a lot of. Okay, now I'm gonna run. Finally! Oh, I'm gonna cry. Let's look at the Python code. I'm going to write the Python code and see if I can run it. I'm going to get a notepad. Where is my Python? ArcPy. Okay, ArcPy. Python win. Python win. Okay, let's do in Python win. Okay, now I'm going to make a new one. New Python script. Okay, that import ArcPy. The only thing is my ArcMap. Right now, import ArcPy from ArcPy. Import environment, and from ArcPy. I doubt that it's gonna work because my version has something wrong. I need some people to look for me. Workspace and equals. I need to put my workspace. Okay. Is it still running? Environment. Okay, environment, workspace. Okay, this is my workspace, okay? Control A, Control C. I don't know whether the workspace could be a database. Let me see. I don't want to put into a geodatabase, okay? Now, then I'm not putting into geodatabase. My data are all here, okay? And where's my data? VA forest, yes. Okay. This is wrong. I have to change everything. It doesn't like this forward. If you do your work a lot of times and like you write one script, and if you are doing similar work that you just change some parameter, and now it's my first time to do it, I think it's gonna take the same time like what I just did the label work. Classify 1. I only want 1. Okay. I just say class equals reclassify. It might not work. Okay, reclassify. Reclassify. Okay. Let's see what's the field I reclassify. Value. Okay, I reclassify value. 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 Okay. Okay, value. Comma. Remap range. Okay. That I have from 0 is 0. Okay. And if no data, no data. Okay. Zero to 0, 0. Okay. 1 to 5. 1 to 5. 1 to 5. It will be 1, comma, and 6 to 15. 6 to 15. 6 to 15 will be 2, comma. Okay, put a comma. 6 to 15. I'm gonna save it. Where's my Python? I'm gonna do desktop. Put it here. Virginia. Forest. Click save. Alright. Okay, then I have a 16 to 25 will be 3. And then 25 to how many? 1274, 1274, 1274, 1274, 1274, 1274, 1274, 1274, 1274, 1274. It will be 25, 1274, classify for 4, and then we have and then we have no data. It will be comma. Okay, no data. Parenthesis. Okay. Okay, I have a re-ramp. Okay, then our classification. I'll reclass 1.save. Then I'm gonna save. It will be the path. GeoDatabase. Okay. I don't know if I can work in GeoDatabase and run. Can I run it? There is an issue. No data after no data. There. No data. reclass. Let me see, reclassify, output, out reclass, reclass, okay, save. Let's run again. Environment, I set up my workspace. It's in D. Import ArcPy. From ArcPy, import environment and import work environment, workspace. Okay, out class. Well, for Python, still need time to work on it. Okay, sorry. I will come back for it. Now I'm going to go to here, symbology. So finally now I have a symbology. We will have to describe the image according to the height classification and what will cause the observed patterns of vegetation. And once we have that, can you see any man-made structures and describe them? Do the build structures seem to have any influence on the vegetation? And we will create a presentation map and export the map to a PDF. I will do that for sure. It's just the layout thing. Now I'm going to save my thing. Okay. Okay. Change the color. The first one, arrows. Okay, this is arrows, and now we'll change it into no color. And the second one, it will be yellow. Okay, then this one will be this green. And number 4, dark green. Yeah, that's how it's gonna look like, okay? And label, the first one is arrows. Okay, then I have a shrubs. Those are shrub, and I will have small raglan. Then I will have a raglan. Okay, raglan. I have to know raglan. Okay, raglan. Okay, small raglan, and I will have a large raglan. Okay, large raglan. Okay, raglan. Regeneration. Okay, regeneration. Raglan means rejuvenation. Okay, regeneration. So, large regeneration and regeneration. Small regeneration, large regeneration, and then we will have a tree. There, very nice. Okay, then we will know some area, and we can calculate approximately where it is. Okay, now I'm going to do is inside map, and we have a DN, and we will have to do a new layout and put everything together. This is DSM. I don't need DM. What happened to my DSM? Oh shoot. I'm gonna rename them DSMM. This one is DEM, okay. DEM. Now I change them. Okay. I'm sorry that DSM, this is DEM, and then DSM, this is DSM, DEM, and we have the height. Okay. And then I don't want to cut everything. Have a map layout. And different legend. Except for the other two. Let me insert. Go to insert, okay. New layout. I'm thinking whether I'm doing a oh, I'm gonna do a landscape. There. So for my landscape, what I'm gonna do is I'm gonna do this, copy it. Copy. Paste. Do 2. And see, okay. Map frame. Height. Put in the middle. Okay. And label and everything will be here, and I think the 10,000. Activate. This is height. Okay, for height, I only need 1 layer. Okay. And I might not need property. Border. Okay. Back to layout. Right click on it and go to property. Okay, border. Gonna do no color there. Okay. So I don't, oh, I don't need no color. Right click on it again. So border, I would just say no border, okay. No border. No color, no border. Okay. There, so this put in the middle, and I'm gonna make it a little bigger. And then I have 1 and 2, and then DN and DN, and my legend. I still want to make this a lot bigger. LiDAR analysis. Put this in the middle. I would say this is height. Okay, now I have height, and I will have forest map frame. I want the where did it go? These are the same, okay. Then I'm gonna change it back. Okay, this one will be LiDAR, okay. I would say study area. Study area, okay. I don't want word imagery. Okay, if I make this study area, I need to look. Okay. Map, base map, topographic, topo, study area, I'm gonna get this big, okay? Go back to layout. I'm gonna delete this. Delete. What happened to the height? Oh, I know what's wrong. Something wrong with the computer. It's rendering. Okay, I will finish the map and I will show you, okay? The Python, I still have to figure it out. I will see you next time.